Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 39 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from number systems. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions as a test, you can log into our portal, the gurukul.org.in. The link is provided in the description below. There you can sign up for free, and once you log in, you will get access to a course called 100 days to CAT, in which there are 3 sections: Quant, VRC and LRDA. We will be uploading 100 tests in each section. So if you are a serious CAT 25 aspirant, you cannot afford missing these tests. And without any further delay, let's get started with the first question. B whole square is equal to MPB, where B, E, M and P are distinct integers. Then M is equal to. So we have B, a 2-digit number, square is resulting in a 3-digit number. Now first let us understand what values can BE take. Right. So BE can take values from 10 to 31. Because 10 square is 100 and 31 square is 961, which is the largest 3-digit perfect square. Right, 32 square becomes 1024. So BE can be any number between 10 to 31. So the values that B can take are either 1 or 2 or 3. Right. So B can be any value, or BE can be a number in 10s or 20s or 30s, and in 30s 30 or 31. Now if the value of B is 1 here, it has to be 1 here. If it is 2, 2. If it is 3 here, that should be 3 here. Now just think, can we have, or do we have any perfect square ending with 3? No. Right. So if you have an odd number ending with 1, square of that will also end with 1. Number ending with 3, square will end with 9. Number ending with 5, square will end with 5. Number ending with 7, square will end with 9. And number ending with 9, square will end with 1. Right. Now similarly, any even number, square of any even number, number ending with 2, square of that will end with 4. 4 will end with 6. 6 will end with 6. 8 will end with 4. Right. So no perfect square ends with either 3 or 2. Right. So the value of B has to be 1. Now if the value of B has to be 1, and to have a perfect square ending with 1, the value of E should be either 1 or 9. Now can the value of E be 1? No, because it is mentioned that B, E, M and P are distinct integers. You cannot have same values for B and E. Right. So the value of E has to be 9 only. So 19 square, 361. So the value of M has to be 3. Hence option B should be the answer to this question. Now coming to the second question. 3 wheels can complete respectively 60, 36, 24 revolutions per minute. There is a red spot on each wheel that touches the ground at time 0. After how much time all these spots will simultaneously touch the ground again? So we have 3 wheels. Okay. So the speed of this wheel is, let us say, 60 RPM. This is 36 RPM. And this is 24 RPM. Right. So there is a red dot touching the ground at t is equal to 0. Now what was asked? After how much time all these spots will simultaneously touch the ground again? So we need to find the time after which they will be completing integer number of revolutions all together. Right. So 60 RPM, 60 revolutions per minute. So what is the time taken to complete one cycle? 60 by 60. That is 1 second. Right. Now 36 revolutions per minute. So what is the time taken to complete one revolution? So that would be 60 by 36, which is nothing but 5 by 3 seconds. And 24 RPM. So the time taken to complete one revolution would be 60 by 24. That would be 5 by 2. Right. Now what was asked? After how much time all these spots will simultaneously touch the ground. So this is 5 by 5, this is 5 by 3, and this is 5 by 2. Right? So indirectly we are asked to find the LCM of these three. So that you will be having this circle completing n rounds, this m rounds, and this some r rounds, where m and r are integers, right? So whenever they together simultaneously complete integer number of rounds, then you will be having the same red spot touching the ground, right? So we need to find the LCM of these two. Now how to calculate LCM of fractions? What is LCM of numerator? 5, 5 and 5. Fine. Now what is HCF of denominators? Because LCM of a fraction is nothing but LCM of numerators by HCF of denominators. Now what is the HCF of 5, 3 and 2? 1. Right. So the answer for this question should be 5 seconds. So after 5 seconds, this will be completing 5 rounds, exactly 5 rounds. This will be completing how many? 3 rounds, and this will be completing 2 rounds, right? So you'll be having that red spot touching the ground again simultaneously. Now coming to the third question, convert 1982, which is in base 10, to base 12. Now whenever you come across a question where a number in base 10 is asked to get converted to any other base, all you need to do is take that number and divide with the new base. Right, we should be writing 1982 in terms of base 12. Right, now what is the quotient when 1982 divided by 12? So that is 1, 12, 78, 6, 62, 5. And what's the remainder? 2. Right, now write the quotient separately and remainder separately. Now let us divide this quotient by 12. 165 when divided by 12. Right, so this will be 1 and 45. That would be 3, right? And what is the remainder? 9, right? Now divide this with 12. 12 ones, 12, and remainder is 1, right? Now you have to do this until and unless the quotient becomes 0, right? So 1 by 12, 12, 0, 0, and the remainder is 1. So the answer for this question should be, you should be writing down the digits in the reverse order, 1, 1, 9, 2. So 1, 1, 9, 2 is the number when you convert 1982 in base 10 to base 12. Hence the answer for this question should be option C. Now coming to the fourth question. P is the product of all the prime numbers between 1 to 100. Then the number of zeros at the end of P are. Right. So let me list down prime numbers from 1 to 100 in the increasing order. 2, 3, 5, 7, 11, 13, and so on. Now we are asked to find the number of 0 at the end of P. Now number of zeros depends on what? Right. Number of zeros depends on number of 2's or number of 5's, whichever is minimum in a product. Right. Now how many 2's do we have in the product of all the prime numbers between 1 to 100? Only 1, because 2 is the only even prime number. So the highest power of 2 is 1. Okay. Now what is the highest power of 5? Again 1. Right. Remaining all 5 multiples are composite numbers. Right. So 5 is the only prime multiple of 5. Right. So the highest power of 5 is also 1. So there will be only 1 0 at the end of the product of prime numbers from 1 to 100. So the answer for this question should be option A. Now coming to the last question. The sum of the integers lying between 1 and 100 both included, which are divisible by either 4 or 7 or both is. Now first let's list down multiples of 4 from 1 to 100 both inclusive. So the first multiple of 4 is 4, then 8, then 12, so on, 28, so on till 100. And let me list down the multiples of 7. Starting with 7, then 14, then 21, 28, so on till 98. Now how many multiples of 4 do we have? You have 25 multiples of 4. And how many multiples of 7? From 7 to 98. 7 14s. You have 14 multiples of 7. Right. Now first let's find the sum of all these 25 multiples of 4. So 25 into, now since they are in arithmetic progression, n into first term plus last term by 2, 104 by 2 plus sum of these. You have 14 terms, 14 into 7 plus 98, 105 by 2. Now you will be having some set of numbers which will be there in both these series. Now what are they? They are nothing but the multiples of LCM of 4 and 7, because 28 is here as well as here. So you are considering this number twice. Now similarly, multiple of 28, 56. Right. Now 56 will be here and 56 will be here. Again you will be having one more multiple of 28. 28 into 3. Right, 84. So we should be subtracting those numbers, minus 28 into, you have 28 into 1, 28 into 2, 28 into 3. So this is 52. Now 25 into 50, 1250 plus 50, 1300 plus 7 into 100, 700, 7 into 5, 35, 735 minus 28 into 6, 20 into 6 is 120, 8 into 6 is 48, 120 plus 48, 168. So 1300 plus 735, 2035 minus 168. Now this is 7, this is 6, this would be 18. Right. So 1867 should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.